Hello again, everyone. Mr. Anderson here with another edition of Algebra 2. We're in Chapter 5, Section 4, so in other words 5.4. We're going to talk about analyzing graphs of polynomial functions. Now hopefully this is going to work out. I've messed with this several times already, but I've got this online calculator thing, and I'm going to try it one more time to see if this works, because I got some cool things that I can show you at the end. If not, I'll just have to show you in class live. But anyway, let's take a look at our objectives first of all. And first of all, we're going to graph polynomial functions and then locate their zeros. We've talked about that a little bit before. And then find the relative maximum and the relative minimum of those polynomial functions. Okay? So first of all, let's start. We're going to just graph a polynomial function by making a table of values. Okay. So all we're going to do is just punch this into our calculator and then graph the points and kind of draw a line to connect them. So let's see if I can get this online calculator to work here. So far so good. All right. So here's my calculator. I'm going to drag it over here a little bit. I'm going to type in negative x to the third. So I typed in the negative sign there already. X raised to the third power minus 4x squared, so 4x squared plus 5. So I've typed that into my calculator there. And remember, if we want to see the table of values, hit second function and then graph, so that gives you the table. All right, so here's, I'm not sure how I'm gonna do this here, but I think that. So then I'll make my x and my y. I wish I could get that to stay on top. And so I'm going to have here, notice negative 530. Okay, so that's going to be like way off the chart up here. So negative 4, 5. Let me try something here. Where did I see this before? Let me try that. This might have been what messed me up before, but so I got negative 4, 5. Oh, good, it's working. Negative 3, negative 4. Negative 2, negative 3. Negative 1, 2, 0, 5, 1, 0. And then 2, negative 19. So that's going to go way down there. Okay, so let's just graph these points here. So negative 4, 1, 2, 3, 4, and then positive 1, 2, 3, 4, 5. Negative 3, negative 1, 2, 3, 4. Negative 2, negative 3. Negative 1, positive 2. 0, 5, 1, 2, 3, 4, 5. 1, 0. And then 2, negative 19 is going to go way down here on the bottom. So we'll just kind of connect those dots then basically. And again, if you want to see about how it's going to look here, remember you can just hit the graph button and it should graph it. So it's going to look something like that. So basically, if I come back over here, this is going to come down. Ooh, it's going to be hard to draw here. Okay, not too bad. So it's going to look something about like that. That's how we're going to graph it, okay? So that's, in this first step, that's all we're going to do there is just make a table of values and graph it. So not too difficult. I'm going to come back to this in a second here and look at a few things. All right, next is the location principle, okay? This one, from this thing that they've got from the book here, makes it look really complicated. But basically all it means is if you've got this point B right here and the y value is positive, the y is positive here, and this point A down here, the y value is negative, when it changed from a negative to a positive or vice versa, that means there's a 0 somewhere in between there, and we've talked about that before. So if I go back, that's why I wanted to jump back here to what we did before. So basically, whenever it's shifting, you can look at it either on the graph or on the table here. When this goes from positive to negative for the y, that means there is a 0 in between there. And when we're talking about the zeros, remember we're talking about the x values. So what that means is here, since this went from positive to negative, one of the zeros is where x is between these two, between -3 and -4. That's one of the zeros. And if you notice, if you look on the graph here, 1, 2, -3, -4, right in between there, that's where we had a 0. Where should another 0 be here? Between -1 and -2, right there, between -1 and -2. Well, if you look here, it goes from negative to positive. Where's that? Between -1 and -2. So also -1 and -2. And then it looks like there's another one here, and it looks like it's right on. It's not changing from negative to positive. It's right on this. And so if you notice right here, y is exactly 0 there. So one of the zeros is, you wouldn't even have to say between there. You would just say it's at 1. Sorry, at 1 when x is 1, because it's right on there. It's not in between. Okay, we've kind of done this before. So let's go to the example for this one then. Okay, so now let's try an example of that, locating the zeros. All right, so let's type this into our equation here. So go up to, if I can find myself, here I am. Go to the y equals button, clear off that old stuff. Let's type in x to the 4th power minus x raised to the 3rd power minus 4x squared plus 1. Okay, so we've typed in that equation. Let's hit second function table. And so again, let's write down our x and y values over here. So now notice we have -373. That's going to be way off there, but let's try -29, -1, -1, 0, 1, 1, -3, 2, -7. Let's see if we got more there. And then they start to get big there after that. So 3, I'm going to write this in here, even though we probably won't be able to graph it, but 319, because that is changing directions there again. It's going from the negative to the positive. So even though we don't graph it, we know it's got to turn back around. Okay, so so what we want to do here is it says, let's figure out where the zeros are. Well, it's going from positive to negative here. So that means one of the zeros is going to be between -2 and -1. Remember, it's the x values we're talking about. Then you notice it goes from negative to positive. So that means we're going to have another 0 between -1 and 0, or between 0 and -1. And then it looks like we go from positive to negative. So we're going to have one between 0 and a positive 1. And then negative, negative, and then it goes one more time here. So also between 2 and 3. So you notice we have 4 zeros there. 4 zeros. By the way, notice we had 4 zeros. Look at what the biggest exponent is, 4. Okay, so that oftentimes will happen. It will never be bigger. If exponent is 4, there will never be more than 4 zeros. 4 is the most it can be. Sometimes it could be less in certain situations. All right, well, let's just graph these points then here. So I got -2, 9, -2, and 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm just going to pretend it's up here somewhere. -1, -1, 0, +1, 1, -1, 2, 3, 2, negative 1, 2, 3, 4, 5, 6, 7, and then 3, and 19 is going to be like way up here somewhere. So just remember it's going to come way back up here, something like that. Okay, and again, let's look at this just to kind of see what it looks like before I try to graph it myself here, but something like that. Okay, so that means this is going to come down here, back up, back down, and then all the way back up here. More or less. It's kind of hard for me to draw with my fake pen here. But anyway, that's basically what it's going to look like, and you can see, yeah, that kind of mirrors what we got on our calculator. All right, good. Next, then, the relative maximum and the relative minimum. I'll move this just a little bit. Hopefully I'll hang on to it there. Sometimes they call them the relative maxima and the relative minima. Basically, the relative maximum is just the point that has the greatest y value that's around any of the other points. So like in this case, a relative maximum would be right there, because all the points around it, that's the highest it goes. It goes the highest and then starts coming back down. Relative minimum over here is the point with the lowest or the smallest y value compared to the points around it. And in this case, there are actually two relative minimum points. One is right here and one's down here. Okay, so this has one relative max and two relative minimums. Notice, and as a matter of fact, and you'll see in a minute here, this one looks like the maximum is right on here, you know, right where x is 0. And again, we're talking about the x values where these are at. And this one, it looks like it's right on where x is -1. This one is like a little off, and so a lot of times we're just going to approximate. So we might say, you know, here this is 2, and it looks like the minimum is slightly to the left of it. So we might say that the you know, the relative minimum is where x is, and the squiggly equal sign means approximately 2. And that's why I got the calculator here, because I'm going to show you at the end how you can find a lot more closely where that actually would be. Okay, so here's example number 3, maximum and minimum points. All right, so again, if you haven't figured out by now, we're going to type this into our calculator. Let me drag it a little closer here. So we're going to y equals, clear that, x raised to the 3rd power minus 3x squared plus 5. All right, second function table. So again, we've got, yeah, that'll be good there. So we're going to go with -2, -15. Uh-oh. It disappeared, didn't it? -1, 1. 0, 5. 1, 3, 2, 1. 1, 3, 2, 1. 3, 5. And then 4 and 21. We won't be able to graph that one, but I'll write it down. Okay, so let's put these in here. -2, -15 is going to be way down here somewhere. And then you've got -1, +1. 0, 1, 2, 3, 4, 5. 1, 3. 2, 1. 3, 5. And then 4, 21 is going to be like way up here somewhere. Okay, so I think you can kind of see how that should look. Let's hit the graph button here to check it out. And that's pretty much what our graph should look like. So we're going to try to draw it best we can. It's going to go up, whoa, you know, more or less like that. You should be able to do better with your pencil on a piece of paper than I can do here electronically. But basically, you can see what the graph looks like. Again, this should kind of come down there and hit that point. All right, so we want to find the relative max and the relative minimum. Now remember, when you look at this, where's the relative max? The relative max, let me just get a different color here. This will be fun. Let's go with blue. So that's the relative max, and this is the relative min. So basically what we would say here, and again, remember, we're just like it was with the zeros. We wanted to find what the x value is. With the relative max and the relative min, we're trying to find out what the x value is there too. So I'm going to say the relative max is where x is approximately, at that point, what's x? 0. Okay, if there's one thing, this is really not that hard, but if there's one thing that people make a mistake on, is they want to try to give the y value. They would say 1, 2, 3, 4, 5. Oh, 5 is the relative max. But remember, we're talking about the x value. So it's the x value. Remember, it even says here in the directions here, estimate the x coordinates. Okay, so x is approximately 0. And here at the relative minimum, what's x there? X is 1, 2. So x is approximately 2. Okay, that's what we would give as our answer there. Now again, it may not be exactly those spots. You know, and as a matter of fact, it probably won't be. Looking at our table here, if you look at our table, if it was exactly at that point at 0 here, well, I don't know. In this case, it's kind of hard to tell. I'm just thinking about the zeros. But let's now check. Actually, let me see. I think I have one more slide here to kind of show you the pattern here, and I'll come back to this slide and we'll kind of find out exactly what these are a little more closely. So here's, if you want to write this down, here's how you check this on your calculator. You can check and find the exact zeros. You can find the exact maximums or minimums. All basically the same way. And when I say exact, I mean as exact as you can get. We're going to round it to maybe 2 decimal places, but a lot more exact than just saying, oh, about 2. So anyway, here's the first thing is go to the y equals button, like we've been doing, type in the equation. Okay, we've done that already. Then you type in second and calc, and then you can choose which one you want to do, if it's the 0, the maximum, or the minimum. So here, this is the equation that we just done already, right? We did the equation. I guess I maybe should have said here, after you type in the equation, you probably want to hit the graph button. I don't know if you have to, but that'll work if you hit the graph button. So you get to this point, now you hit second function right here, and then this is the calc button above trace there. See, now look at calculate. You got 0, minimum, maximum, and there's some other stuff here too. These are the ones that we'll use right now. So if we're going to try to find, let's try to find the maximum on what we just did. So I'm going to choose number 4. Now here's what it'll say. It'll say left bound. Okay, so using your arrows here, see the little blinking thing here? Just move it to the left, somewhere to the left of your maximums, right in here somewhere. Just somewhere to the left of that, and hit enter. Which, by the way, let me jump back over here. That's what I just said. Move the cursor to the left of the point, hit enter, which we did. Then you move the cursor to the right of the point and hit enter, enter, and you'll see in a second what happens there. So now I'm going to move, it says right bound, so I'm going to move this till I get somewhere to the right of that maximum point, and I hit enter. Now look what it does. It's like, guess? No, I really don't want to take a guess at it. Why don't you just tell me? So just hit enter again. You don't have to guess. And then in a second, right down here, it'll tell you maximum x equals a negative 1.15. It looks like, is that, that's what it's, or maximum negative, that doesn't make any sense. Oh, here we go. That's why it threw me off. Notice, look real closely. It's a negative 1.15, whatever that is, 3. E negative 6, that's like 10 to the negative 6th power. So be careful. Sometimes this will throw in a scientific notation. Basically, that just means that's virtually 0. There's 6 zeros in front of this 1. So if we rounded that to 2 decimal places, it would actually round to 0. But so it's very, very, very close to 0. And then if we wanted to find the relative minimum, you just kind of do the same thing. Second function, calc. Let's go down to number 3, minimum. And then left bound, just move it somewhere so it's to the left of that point. Enter. Right bound, move it over to the right of that point somewhere. Enter. Guess. No, thank you. Enter again. And it will tell me 2.000021. Again, if we rounded that to 2 decimal places, that would round to 2 exactly. So you'll have a few examples where they'll tell you to use your calculator and round these to 2 decimal places. So in both of the cases on that one that I just had, it rounded, to 0 and then to 2 for the maximum and the minimum. But on the ones that you have, it will actually, you'll get some different numbers there where you'll round it. So anyway, but that's how you can check. And as a matter of fact, when we're finding zeros, if you want to find the zeros a lot more closely, like for example here, you can just go to number 2 and hit a 0. Now you notice, remember the 0 is where it crosses the axis here. So you could just do the same thing. Move your point somewhere where it's to the left of the 0. Enter. Move it to the right. Somewhere past there. Enter. Enter. And it will tell you you have a 0 at a negative 1.10 it would round to if you went 2 decimal places. So not quite at a negative 1, but negative 1.1, basically, very close to that. So that's how you could find out more precise values using your calculator. Anyway, that's it. I hope you enjoyed my newfound calculator. Oh, look at that. I can make it bigger or smaller too. Isn't that exciting? Ooh. My newfound calculator friend, and hopefully that will continue to be able to work in the future for us. So anyway, thanks for being with me. Section 5.4 signing off. We'll see you next time. Bye.